All right, guys, we're going to finish up the review sheet today, and your test is tomorrow. So where we finished up on Thursday was problem number 26, finding the least common multiple.
Did a lot of it on my phones. Actually pretty understandable whenever I watch the video.
Yes, and the test for the most part I think is one of the easier ones, especially if we know the least common multiple. Possibly, I don't think you will. Especially if you watch the video, these here are only going to count for 2 problems. So if we look at 27, with most of this here, especially with addition, subtraction, multiplication, factoring, we just need to factor it. So x squared plus 3x minus 40. We'd have our 2 sets of parentheses with 3 spaces. Now there's not a greatest common factor to factor out, so we don't need to do that. Since the third term's negative, our signs are opposite. Factors of x squared would be x and x. Okay, I'll have to get it a little bit, yeah. 2 and 20, 4 and 10, 5 and 8. 4 and 40, 2 and 20, 4 and 10, 5 and 8 are all the factors. 5 and 8. And if we check this here, we don't have to do x times x, but our x times negative 5, negative 5x. 8 times x would be plus 8x, giving us positive 3x. And that's the middle term we wanted, yes? Now we would factor the other one, but our x minus 8 is actually already factored. That's as simplified as it gets. Least common multiple is the first expression that will make both of these be the same. We can start with the left, so we need at least one x plus 8, because it shows up in one of them, so we'll need it at least once. Does x plus 8 show up in any of the others? Well, now it's x minus 8, so we just need it once. Our other one is x minus 5. We need it once, because it does show up in one, but it doesn't show up in the other one, so we just need it once. And the only other thing we need is x minus 8. Actually works out we just grabbed all of them, because they all showed up once. I'm going to look at 29 next. So the first thing we need to do is to factor both of these here and go from there. Now we could start off with our 4x squared minus 16. We should always be looking for a greatest common factor between the terms. And 4x squared and 16 have a greatest common factor of 4. Leaving us with x squared minus 4. X squared minus 4 can be factored. It is a difference of perfect squares, giving us x plus 2 and x minus 2. So that's completely factored. Now we're going to go on and factor our 6x squared minus 24x plus 24. Well, there is a greatest common factor of 6. If we factor the 6 out of 6x squared, we have x squared. If we factor the 6 out of 24x, we have minus 4 plus 4. So the first thing we would do is factor the 6 out. Now we need to factor the x squared minus 4x plus 4. Since the third term is positive, the signs are the same and match the sign of the middle term. Minus and minus. Factors of x squared are x and x. Now our factors of 4 are 1 and 4 or 2 and 2. We would need 2 and 2. So both of these are factored. Because once we get them completely factored, then we can find the least common multiple. we'll look at the least common multiple of 4 and 6 last. So let's do our sets of parentheses because they're a little bit easier first. The one on the left has an x plus 2. So we need at least once, yes? Does the one on the right have it at all? No. So we only have x plus 2 once. The other one we can look at is x minus 2. So it is show up 3 times. The one on the left has it once. The one on the right has it twice. So how many times do we need it? Whichever one has it the most. Here it's 1, here it is 2, so we need it twice. Because they both have it once, so that's fine. But since the other one has it a second time, we need it twice. Questions on how we found the multiples of our least common multiple of our sets of parentheses. 4 and 6. We're trying to find the first number that makes 4 and 6 be the same. Going up. Well, the easier way to do this is just looking at the multiples of 4 and 6. And well, the first number that 4 and 6 are the same is 12. And when I wrote the multiples out, it's just 4, 8, 12, 16, 20. We're just going by 4s. And with 6, 6, 12, 18, 24, 30, just going by 6s. And 12 is the first number that we can turn both 4 and 6 into. So 12 is its least common multiple. Telling us that the answer for this here is 12 times x plus 2 times x minus 2 times x minus 2. So that's the first expression we can turn both of them into. Questions on this here? And again, there's only 2 of these on the test, so they're not a huge portion of it, especially if you're getting stuck here. So, do we want to look at 31 or 32? 32. Now, the first thing we want to look at when doing these here is restrictions. Normally, we would do restrictions. And unless it says in the instructions, because it will say, watch out for restrictions, we don't necessarily need to find them. Because if we're finding the restrictions, all we're doing is setting what our denominators are equal to 0 and solving. To determine what values of x will make the denominator be 0, because if we get one of these values as a solution, it won't work. For x minus 3, we would add 3, telling us x cannot be 3. For our x squared minus 27, well, we would add 27 to both sides, telling us x squared is equal to 27. From here, we can square root both sides, telling us x is equal to plus or minus the square root of 27, which is actually 3 square root of 3. And we could find that by plugging that into the 30xs, but we get this here. So if we solve this here and get a value of 3 or positive or negative 3 square root of 3, then those values don't work. We have to remove them from the solution. Now that does tell us a few things. One, that x squared minus 27 doesn't factor. Because if it did, we would have a nice number, not 3 square root of 3. So we don't have to factor it. Now our first step in solving, we can jump right into that, is to multiply both sides by x minus 3. Because on the left side, the x minus 3 and x minus 3 would cancel. We're also going to have to multiply this by x squared minus 27. Because on the right side, those would cancel. And what that leaves us with is negative 1, negative times our x squared minus 27 is equal to x minus 4 times x minus 3. Now we're going to distribute. For the left-hand side, we'll distribute the negative, giving us negative x squared plus 27 is equal to. Here, we're going to distribute the x. X times x is x squared. X times negative 3 is negative 3x. Negative 4 times x is negative 4x. And negative 4 times negative 3 is plus 12. Now, before we do anything else, we'll want to combine like terms on either side, so that it's a little bit easier to work with. Questions on this here? Now, since we have x squared terms, we need to get this equal to 0, so I can add x squared to both sides, telling us that 27 is equal to 2x squared minus 7x plus 12. Then we can subtract 27 from both sides, telling us 0 is equal to 2x squared minus 7x minus 15. Questions on how we got to this point here? Now we can try graphing these. And when we graph this here, we do have one solution that does show up, which is 5. Now on all of them, except for one on the test, there's only one that we're going to actually have to factor to solve. Because it did tell us x is 5. We have to find the other one. Since the third term is negative, our signs are opposite. Factors of x squared are x and x, 2 and 1. So I'm just picking which one to put it in for now. Factors of 15 are 1 and 15 or 3 and 5. And again, at this point, we can check and make sure. 2x times negative 5 is negative 10x. 3 times x is plus 3x, giving us our middle term of negative 7x. And again, whenever we have two or more things multiplied together to equal 0, one of them must be 0. For the one on the left, we would now subtract 3, telling us 2x is equal to negative 3. Divide by 2, telling x is negative 3 halves. For our x minus 5, well, add 5, telling us x is 5. We already had that. So these are our two solutions. Since the restrictions were 3 and positive or negative 3 squares of 3, they didn't show up, so both answers work. Questions on this here? So the only ones that the restrictions will show up, the directions for those problems will specifically tell you there's going to be a restriction. We good with this one here? All right. Let's look at 34. Now, we can look at restrictions for this one here, but before we do, if one of the denominator's factors, we need to factor it. The only reason we didn't do that on the last one was because, well, x squared minus 27 didn't factor. Bless you. And the one that factors here is our x squared minus 1. It's a difference of perfect squares, telling us that the two factors are x plus 1 and x minus 1. So if we look at the restrictions for this here, there's three places that we have restrictions or could show up. One of them is where it's x plus 1. The next is where it's x minus 1. And well, the third one is where it's x plus 1. So we only really have two restrictions that'll show up. One of them shows up twice, but we only have to find it once. For x plus 1, we would subtract 1, telling us x cannot be negative 1. For x minus 1, we would add 1, telling us x cannot be 1. So if we get positive 1 or negative 1 as a 0, we just mark it out, and it's removed from the list. Now, here we can start solving. By multiplying everything by x plus 1 and x minus 1. Because on the far left, the x plus 1 and x plus 1 would cancel. The middle, the x plus 1 and x minus 1 would cancel. And since our 3 doesn't have a denominator, nothing cancels, leaving us with 4x plus 1 times x minus 1 is equal to 12 plus 3 times x minus 1 times x plus 1. Now we need to distribute 4 times x is 4x squared. 4 times negative 1 is negative 4x. 1 times x is plus x. 1 times negative 1 is negative 1. Well, at this point, we can still do the distributive property. X minus 1 times x plus 1. What would that multiply together to be? Well, where do we get x plus 1 and x minus 1 from? The factors of x squared minus 1. We already factored it earlier, yes? Well, if we're multiplying them back together, it should go back to that there. Now, at this point, if you went on and multiplied it out, x plus 1 and x minus 1, you would still get to the same spot. Because it would just end up being x squared plus x minus 1, which is x squared minus 1. We'd still get there. It just cuts a step out. Now, at this point, we're going to combine like terms on the left-hand side. The right-hand side, we're going to distribute the 3, giving us 3x squared minus 3. At this point, we can finish combining like terms, because we had combined like terms on the left-hand side, but after multiplying through by 3, we had 3 and negative 3 and 12 that are like terms, and we can combine. If you have an x squared term, get the equation equal to 0. If you just have an x term, x to the first, get it by itself. So here the first thing we can do is subtract 3x squared from both sides. So like I said, we have x squared minus 3x minus 1 is equal to 9. Now, since it's still not equal to 0, we can subtract 9, telling us x squared minus 3x minus 10 is equal to 0. Now, just like the last one, we can factor this. 2 sets of parentheses, our signs, go through the whole process. Or we can also graph it. X squared minus 3x minus 10, yes? Yep. We see it crosses at 2 points. Negative 2 and 5. Because when we graph it, we're looking for what values of x make the y value be 0. We're only caring about what values of x makes the y be 0 when we graph. Negative 2 and 5. Nope. So these here are our solutions. We only put the line through it for our restrictions. So for this one here, x could not be 1 or negative 1. Because that was the restrictions at what made x, or the denominator of this equation, be 0. So we remove those. That's why we use the line. Here, these are our actual solutions. And since neither one of them is our restriction, they both work. And that's it. Let's look at 35. What do we need to multiply everything through by? Well, we have 3x and 6, yes? Well, we know for sure I'm going to have to multiply everything through by x. Because if we do this x and this x cancel. Nothing in the middle. So we can do 3 and 6. But what's the first number that 3 and 6 will both be? What's our least common multiple for 3 and 6? 6, yes? We can use 3 and 6, or we can just use 6. Now, if it's just a number, it's not going to hurt us too much. It just means that we'd have to divide it out at the end. That works fine. Numbers are not bad. It's variables that we have to be careful with. Because if we do this here, I'm going to go on and just write this part out so we can see it. Is what we have left if we're doing the 6. Because numbers are a little harder to see than just expressions. Here, 3 over 6, all the 3 becomes 1, the 6 becomes 2, giving us 2 times 2, which is 4, plus. Well, the middle one's nice because 6 over 6 is gone. X. 2 over 1, 4 times 2 is. This time, do we have an x squared term? No, get x by itself. Done. We didn't list the restrictions for this one, but the restriction is just x can't be 0. Because 3x, the only value of x that will make 3x be 0 is 0. I did do this one in the full video twice. I did it once where we did 3x and 6, multiplied through everything, and this here. You'll get to the same spot, but the only main difference is here, instead of it being x, or 4 plus x equals 8, I believe we get x plus 2x equals 16. Because 6 over 3. 6 divided by 3 is 2. Yeah, that's why there's a 2. So essentially, I removed that factor without doing a step in between. So we divide it, then do 2 times 2 plus x plus equals 4 times 2, and then one more time. Questions on this here? All right. $36, $37, $38, $39. Which one do we want to look at next? Up to y'all. $38. $38. Are all the denominators factored? Well, x minus 2, yes. Are x squared plus x minus 6? It is not. To factor it, greatest common factor, there's not one. Since the third term's negative, our signs are opposite. Only factors of x squared are x and x. Factors of 6 are 1 and 6, or 2 and 3. For us here, I'm going to go on and give it to us that it's x plus 3, x minus 2. Restrictions. So x plus 3 cannot be 0, and x minus 2 cannot be 0. Because if either one of these is 0, we get the division of 0. Doesn't work. So we set them equal to 0 and solve. So if x is negative 3 or positive 2, those solutions do not work. No idea. All right. Questions on this so far? So let's multiply through. So let's see. So guys, focus in. So that is a good question if we need to put it once or twice. So if there's ever a question if we need it more than once, use it once and go from there. So if we look at x minus 2 specifically, on the far right, x minus 2 over x minus 2 would cancel. Because we have one on bottom, one on top, so they cancel out. Yes? Middle, there's no denominator, nothing simplifies. On the far left, one of our x minus 2 on bottom cancels with one of the ones we're multiplying. Yes? Are there any x minus 2's left? No, so do we need it again? No. And that's one of the ways we can do this. If there's a question, if we need it more than once, multiply through once, see if it's still there in the bottom. If it is, multiply it again. If not, we're good with 1. And the only other denominator we had was the x plus 3. It cancels out, leaving us with 5 is equal to 2 times x plus 3 times x plus minus 2 times plus x plus 3 times or x minus 3. Yep. But again, I would take this one step at a time. So even though we know some of this stuff will simplify, we're just rewriting it back out. All right. Equals 2 times. Yes. Okay. I'll fix that. We'll see here in a second. It might be something I need to fix, but we'll see. X plus 3 times x minus 2. Didn't we factor those earlier? So this x squared plus x minus 6. If we don't notice that, especially on the test, you're going through and miss that, that's not a big deal. Because again, you can multiply those two together, you'll still get to the same spot. X minus 3, x plus 3. Well, it is a difference of perfect squares, yes? So it would multiply together to give us x squared minus 9. But again, multiply it out, we'll still get there because the positive 3x, negative 3x becomes 0, giving us this here. Now for other part, we'll distribute the 2, giving us 2x squared plus 2x minus 12. Now before we move anything, we do need to combine like terms. 2x squared plus x is 3x squared plus 2x minus 21. Questions on this so far? Okay. Yep. Okay. Sorry, I'm just Okay. Ah, no. You mind if I look at your review sheet real quick for that negative? Okay, yep, that is negative. We'll leave it there. I believe the other video I have it as positive, but that's fine. So we'll add 5, telling us 0 is equal to 3x squared plus 2x minus 16. The only reason I paused was I was wanting to see what values we got it as positive instead of negative. Now, one of the giveaways that we're going to have to factor is if there's a number in front of x squared. There's no greatest common factor, so it has to stay there. Since the 16 is negative, our signs are opposite. Factors of x squared are x and x, 3 and 1. It doesn't matter where we put it, we just got to put it in one of the two places. Factors of 16, 1 and 16, 2 and 8, 4 and 4. As much as I want to do 4 and 4, it's going to be 2 and 8. Because if we check this here, 3x times negative 2 is negative 6x. 8 times x is plus 8x, giving us 2x. Since we have 2 or more things multiplied together to equal 0, one of them must be 0. So for our 3x plus 8, we would minus 8, telling us 3x is negative 8. Divide by 3, telling us x is negative 8/3. Two and negative 8/3. Is either one of these our restrictions? 2 is, yes? Well, 2 is a restriction, so might be that one. And that's it. What does the answer sheet say this one is? Negative 8/3? Yep, that's it. The video will be different because I did it as positive 5, not negative 5. Process, everything's still the same. It's just going to throw out negative 3 instead of 2. Funny enough. Questions on this here? And this one here? Yes, I can go through and work on this one here. Through it, I'm probably going to run through the bell. But most likely this one is going to be more closer to the bonus than it is anything else. We've covered everything else. If there are any of the others that you want to see, either ask or watch the full video, because everything, yeah, email me. I feel like you're probably going to be fine. Yeah. No, I don't think so either. One of the things I will point out, guys, is if the numerator factors on solving, leave it be. Don't touch it. The only time we have to factor the numerator is with multiplication and division, but at that point with division, it's just multiplication. I'm going to go on and just give you the factors since we're running short on time. So our restrictions are from x plus 2, x minus 1, x plus 1. All we need to do is solve these here. So x cannot be negative 2. X cannot be negative 1. and x cannot be 1. Because if we get any of these three here, the denominator would be 0. And funny enough, as bad as this looks, it actually works out to be quite nice. Because we are going to multiply by x plus 2, x minus 1, and x plus 1. On the far left, x plus 2, x plus 2, x minus 1, x minus 1. The middle, x plus 2, x plus 1. And the last one, our x plus 1 and x minus 1. Leaving us with x times x plus 1 is equal to x times x minus 1 minus x times x minus 2. So even though we had so many sets of parentheses that we had to multiply through, this is all we're left with. Distribute. X times x is x squared. X times 1 is x. Here we'll do the same thing. X times x is x squared. X times... Yes. Plus. Thank you. Negative x times x is negative x squared. Negative x times 2 is negative 2x. Combine like terms. So we'll finish this up here. These, because positive and negative cancel, telling us x squared plus x is equal to negative x minus 2x is. Now that we've combined all of our like terms, and we have an x squared, we need to get it equal to 0. So we get x squared plus 4x equals 0. There's no number in front of x squared. So we could graph it or factor it, either one. X squared plus 4x equals 0. Two places it crosses at negative 4 and 0. Because again, we're looking for what values of x make the y value be 0. That's it. If you have any other questions on this here, please